We were given a problem to test whether it was feasible to throw a cricket ball over the roof of a house and then catch the ball on the other side before it hits the ground. In deriving this solution, we considered amongst other things the path which the cricket ball would take, what angle the ball would need to be thrown at, and how fast you would have to run to get there in time. Firstly, we drew a diagram of the problem. H is the height of the house in certain places, so we have a H1, a H2 and a H3, and likewise L is the length in certain places respective to those H's, L1, L2 and L3. We then determined the following key variables. X is the horizontal distance of the ball at any time, and Y is the vertical distance of the ball at any time. We associated these variables with the mathematical notation commonly adopted from the study of mechanics, using Suvat equations and projectile motion. We then derived three simple conditional statements around the vertical displacement based upon the length of the distance travelled. When x is equal to L1, the vertical displacement must be greater than h1. Y must be greater than h1. When x equals L2, the vertical displacement must be greater than h2. Y is greater than h2. And when x is L3, the vertical displacement must be greater than h3. Y must be greater than h3. For our different values of h and L, we use the average height and length of a two-storey house in the UK. We took our U to be the speed at which a cricketer can throw a ball from the boundary into the wickets. We then used these conditions and considered Suvat vertically to come up with three quadratic equations to get a range of angles where the ball will go over the house at these different points. We take the intersection of these three solution sets because the ball must go beyond all 3 points on the house. From these equations, we got that theta must be between 44 and 72 degrees. At 44 degrees, the ball takes 2.6 seconds to complete its flight path. This is quite a short time to run the required distance, so we will take the maximum angle. At 72 degrees, the ball takes 3.58 seconds to complete its flight path. This gives the person who throws the ball 3.5 seconds to run 27 meters. They should run at an average speed of 7.6 meters per second, which is possible for most cricketers. For an example, Usain Bolt averages 10.4 meters per second in 100 meters. One also needs to take into consideration the other factors, such as wind conditions or the individual running through the house. To conclude, it is possible.
Oh, yeah.
Thank you very much. We've been Group 6.